Hey dudes, Dude the Builder here. In this episode of Zig and Death, we're going to be talking about interfaces in Zig. First of all, I want to make a quick shout out to Uwe Hagmeyer, I hope I pronounced the name correctly, who kindly made a donation to Dude the Builder channel. And I really appreciate it. It helps support the channel and allows me to make more content like this. So you'll find a link to the PayPal donations page in the description of the video and also on the channel homepage itself. Okay, so thank you, Uwe Hagmeyer. So back to interfaces in Zig. It's an interesting topic because Zig doesn't have interfaces as part of the language itself. But like many other things in Zig, you can make them yourself from the building blocks that Zig does provide, being a low-level language. So basically in Zig, you can construct a mechanism that's equivalent to what you find in other languages that do have interfaces as part of the language. And since you're building it yourself, you can even have more flexibility than other languages, okay? So the first thing that we're going to be looking at is we're going to be starting at the end. So basically we're going to be looking at how to use the interface that we're going to be inspecting here. It's going to be called stringer. So basically a stringer is anything that can turn itself into a string. And here what we're going to be doing initially is importing a version of the stringer interface that's implemented via a tagged union, which is the easiest way to implement interfaces in Zig. It's also, there are benchmarks that have proven that this is also the most performant way, the most efficient way of implementing interfaces in Zig. With the drawback that it's basically a closed interface type, so you have to have control over the source code in order to add implementations, and we'll be seeing that in a moment. But here we are importing that interface type here called stringer, okay? And here we have a function called printStringer that takes an instance of a stringer, and what it does is it provides the toString method of the stringer, which is basically the principal method of the interface. This buffer here of 256 bytes, and what we're going to be obtaining is a slice of that buffer that contains the string version of whatever stringer was passed in to this function. And then we just do a debug print of that string, okay? So here in our main function, we are creating here an instance of a stringer. And as I said, this version of the interface is implemented via a tagged union. So being a tagged union, we have here one of the fields of the tagged union, which is called user. And that user is a struct type, which we'll be seeing in a moment, of type user also, which has two fields, the name and the email, which are both strings, okay? And once we have an instance of that field of the tagged union, we can pass in directly to our printStringer function that instance, because it in fact implements that interface, okay? And here, to demonstrate that indeed we're dealing with a polymorphic interface, we have another variable called Donald. And this one is another field of the stringer interface called animal. And it has two fields also, two string fields. One is the name and one is the greeting, okay? And then, once again, we can pass this other instance of that tagged union here to the same printStringer function, okay? And if we run this program, we'll see that we have the two strings which are unique to each type of implementation of the interface. In the case of the user, we have this type of output. And in the case of animal, we have this type of output. Okay. So now let's go and see how this is actually implemented in Zig. As I said, our interface here is a tag union, which is a union that has an enum here, tag type. And we have two fields. One is user and one is animal. And user is of type user, animal is of type animal. And we're going to be seeing those definitions in a bit. And we have the actual method here for the interface, toString, which takes an instance of this interface type, and a buffer, which is basically a slice of U8. We're going to be returning an array union and a slice of U8. And basically what we're going to be doing is here we're switching on self, which is the stringer type, which is a tag union, and we can switch on a tag union. And we're going to be using the inline else here, which will expand to all of the fields that we have here, which are basically these two. And for each one, we will be calling the specific toString method of that captured instance that we have here in the capture. And we'll be passing it the buff, and that's what we're going to be returning here from this function, okay? So basically here is the part that we are doing what's known as the dispatch of the actual implementation of toString. And here we have the definitions of our implementations, okay? We have a user type here, the name and the email fields, which are strings, slice of const U8, and the actual implementation of the toString method here that takes a user here and the buff, and we simply use here buff print from stud funct to actually print out this text into that buffer, and that's what we will be returning, okay? Here we have the other implementation, which is animal, also a struct, have two fields here, and we're basically doing exactly the same thing with stud funct buff print, okay? So as you can see, the interface is the tag union. And when I said that this has the drawback of being a closed implementation type of interface, is that when you want to add other implementations, you have to add them here directly into this tag union, okay? So you have to have control of the source code of the interface itself in order to add more implementations. But if you do have that type of control, then this is the best option, the most straightforward and easiest option, and also the most performant option, okay? And that's what we saw over in our main.zig. That's what we were using, okay? Now let's comment this out. Let's uncomment here. Now we will be making use of the other type of interface that we can build in Zig. And this type makes use of pointer casting, and this is basically the type of interface that you're going to find in many places in the standard library. For example, the reader, the writer, and the allocator interfaces in the standard library. They basically use this method that we're going to be seeing next. So we import here the stringer interface itself, and our animal and user implementations, we are also importing them, and we are importing them aside from the interface, because now we're not using the closed method as the case is with the tag union. Now the implementations can be totally separate from the interface itself, okay? And this print stringer function doesn't have to change at all because the interface is exactly the same, okay? So we can comment all of this out, okay? And now let's uncomment this code over here, okay? And what we're doing here now is once again instantiating our implementations. But as you can see now, it's not a tag union, it's directly a struct here of user type. We're defining it here with the name and the email. And as you can see here, to obtain the actual implementation of the interface for this struct type, we call the stringer method, okay? And this is just like, as I said, the other allocator, the other interface implementation examples that we can find in the standard library, like for example, the allocator. If you remember, if we have like a general purpose allocator instance, to obtain the actual allocator interface, we call the allocator method, okay? So basically, when we call that method, we obtain the actual implementation of the allocator interface that the general purpose allocator provides. So we're doing the same thing here. We are obtaining here the actual implementation of the stringer interface that the user struct provides, okay? And then we pass that implementation to our print stringer function. And we do the same thing here with animal. We obtain here, once again, the actual implementation calling the stringer method, and then we pass that implementation to the print stringer function. So let's save this, and let's run our program. And as you can see, we obtain exactly the same output, okay? We have the implementation for user and the implementation for animal, okay? So now let's take a look at the source code for that. Here, the interface now, instead of a tag union, we have a struct. This is the actual interface definition. And what we're going to see here is one of the key elements of how we implement this type of interface is this pointer field, which has type pointer to any opaque. Any opaque in Zig is basically a type that says this is a black box. We don't know what this is actually, what the details of this type. This is also what's known as type erasure. Once a type is assigned to this field and it's coerced to any opaque, then we lose basically all the details about the specific type. But this is necessary because in order to accept any type of object here that wants to implement the interface, we need a type that can accept any other type, and any opaque can do that. And it's a pointer because any opaque doesn't have a known size, okay? And you have to, when you're creating a struct type and you have a field, you have to know the size at compile time. So pointers always have a size that's well defined at compile time. It's the word size of the architecture. So this field being of type pointer to any opaque gives us a size and to satisfy the compiler. And here is where we're going to specify the type of the actual function of this interface. You can have interface with more than one function, okay? And what's done in that case is that usually we define like an inner struct within this struct called the vtable struct, and that struct's fields are going to be the different function types of the interface. But since this interface only has one function, we can directly add it here as a field to the stringer struct. And this is going to be a const pointer to a function that takes a pointer to an any opaque. It takes our buffer of bytes, a slice of U8, and it returns any error union with a slice of U8, okay? And here we have the actual method that we can call on an instance of this stringer type. It takes a stringer as its first parameter, so it can be called as a method. And it takes the buffer as the second parameter, okay? And it once again returns the error union with the slice of U8. And here what we're going to be doing is calling precisely this toString fn field, which basically is the one that's going to provide the actual concrete implementation of our interface for each type that implements our interface, okay? And we pass in the pointer as the first field, as we are saying here, the pointer to any opaque. We are passing here our field pointer. So we can use that field within the interface implementation to obtain the actual type. We're going to be seeing that in a moment. And the buffer, okay? And now here we have the first implementation of this interface here, the user type. We have the name and the email fields as before. And we have here the implementation of the toString method. As you can see, we are, the first parameter is our pointer here, pointer to any opaque, and the second one is the buffer. And here is the second part of how this type of interface is possible in Zig, okay? Here is where we're going to be casting this any opaque pointer to the actual type of our implementation with this, which is a pointer to a user. So here what we're going to be doing is using the built-in pointer cast and align cast, okay, of that pointer to any opaque. And the align cast, what it's going to do is the pointer to any opaque has alignment of 1 because we don't know the actual alignment of the type that we have in memory. So align cast is going to cast that alignment to the actual alignment of here, a pointer to a user. And the pointer cast is going to cast the actual pointer to any opaque, will cast that to pointer to user. So now here we can use that self instance in our call to std_buff print. As you can see here, we're using that self, and we are dereferencing the pointer because buff print needs the actual value and not the pointer itself. But here self is a pointer to a user. So we have the details about the email field and the name field, okay? So basically this is the heart of how we implement this type of interface here. This pointer cast, align cast combination is what allows us to convert what was the type erased pointer to any opaque to the concrete pointer to user. And then we can use that, okay, as our self instance. And here we have this convenience method that we used in our main function in main.zig. The stringer here method, which basically will return the actual stringer interface here. And what we do is we assign self, which is a pointer to user, to the PTR method field, sorry, and this will coerce this pointer to user to a pointer to any opaque. And here the toString fn is the function definition of the user type of the method toString. Okay. So here the animal implementation is basically going to be doing the same thing. We have here the pointer cast, align cast, but this time casting to a pointer to animal. And here we have the stringer method, which returns the implementation here as the method toString of animal. Okay, and that's basically it. That's all the code that you need to implement this type of interface. Here we have these implementations directly in this file, but the user and animal structs could be implemented in separate files or even in separate libraries. The only important part is that they satisfy the details of this stringer interface. Okay, and as you can see here in our main file, in our main function, we just create instances of those struct types and then call the convenience stringer method here to obtain the implementation, which we can then pass to any function that expects an implementation of that interface. Okay. So with that, that's basically what I wanted to cover about interfaces in Zig. As you can see, we have the tagged union type of interface, which is the easiest, most straightforward, and most performant type of interface you can implement if you have control over the entire source code of the interface and the implementations. And if that's not the case, then you can use a more general type of interface, which is what we find in the standard library, allocator, writer, reader types of interfaces, which makes use of the pointer to any opaque, and then later on the pointer cast align cast combination. Okay, And with that, you can basically implement any type of interface that you want in Zig, okay? I hope you find this useful in your projects with Zig. Dude the Builder here. I'll see you in the next one.